Hello students, my name is Liliya Turovska and we have lesson 1, Differential Calculus. In this video we are gonna focus on finding derivatives, and we're about to consider derivatives of the simplest functions, power rule, sum rule, product rule, quotient rule and chain rule. So let's start with the basics. We consider the derivative of the constant function. And derivative of any constant is 0. So, generally, if we have some constant, c is constant, derivative is 0. For example, if you have 5, derivative of 5 gives us 0. If you have 10 to 5th power, we get 0 again. We have pi. If pi is constant, derivative is 0, and so on and so forth. So the next simplest example is the power rule. What is the power rule? If we have x raised to nth power, how to find derivative? N moves to the front. We have x in power n minus 1. So the power is decreased by 1 and we get n on the front. N is any constant number. Let's try some examples. If we have x squared, according to this formula, we have 2 on the front times x and 2 minus 1. So what we get? We get 2x. The next example, similar, x to 6th power. Again the same, 6 moves to the front, times x, subtracted by 1, 5. 6x to the 5th power. The same, x to the 10th power. You may pause the video and do it on your own if you want, and then check the answer. We have 10x to 9th power. One more example. What if we have simply x, derivative of x? It could be confusing, but you should know that what is x? It's x to the 1st power. So what we get? We have 1 times x. 1 minus 1 is 0. Any number to 0 power is 1. So we get 1. Just remember that derivative of x is 1. What if we have some number in the front of the function? So if we have any number in the front of the function, c times u, where u is any function, we find derivative of u, but c we leave the same. So we do not change the multiplier. We just find the derivative of the function and multiply by this constant multiplier. For example, if you have 4x squared, 4 is the constant value, we leave it without change, and times derivative of x squared. So according to the formula we have on the top, we do not change 4, find the derivative of the function. So what we get? We get 4 times 2x. 4 times 2 is 8. So the answer is 8x. Another example, if we have, for example, 10x to the 7th power, we rewrite 10, and derivative of x raised to 7th power, you already know, it's 7x to 6th power. 10 times 7 is 70, x raised to the 6th power. That's the answer. Okay, if we have the polynomial function, we should use the sum rule. We apply this sum rule. What is the sum rule? Here is the formula. If you have two functions, u and v, so derivative of u plus v, what we get? We should find derivative of each one separately. So we should find derivative of u plus derivative of v. So we simply separately find derivatives of these functions, and here we have the example. We have such polynomial function 10x cubed plus 5x squared plus x plus 5. We can rewrite it as the first function is 10x cubed. It's not necessary to do like this. You can find a derivative without this step, but we should explain the derivative of this function. So according to the formula, we look for derivative of each function separately. So what we have, the first function 10x cubed, 10 the same, derivative of x cubed is 3x squared plus 5, we write 5 times 2x plus derivative of x is 1 and derivative of 5 is the constant number, so derivative is 0. So when we rewrite, we'll get 30x squared plus 10x plus 1. That's all. Let's try one more example. Let we have this function x to 6th power, excuse me, x to 6th power plus 2x4 minus 3x squared minus 4x minus 6 and derivative. Find each derivative separately. Derivative of x power 6 is 6x5 plus 2 into derivative of x4 is 4x3 minus 3 times 2x minus 4, derivative of x is 1 and derivative of minus 6 is 0. We do not write this. And what we get? 6x fifth plus 8x cubed minus 6x minus 4. That's the answer. And the first example is 1 over x cubed is. Have to find this derivative. First of all, we should move x cubed to the top. What we get? X, but the positive 3 changes to negative 3, so we will get x minus 3. We do not find derivative yet, we just rewrite the function, and what we can do now, we can use power rule. What it gives us? We have minus 3 moves to the front, and what we get? X to the power minus 3 minus 1. We get minus 3x to the power minus 4. We may leave it like this, but better to bring x back to denominator. What we get? We have minus 3 over x to the 4th power. One more example. 1 by x to the 4th power. Again, we rewrite it and we get it's x minus 4, derivative x minus 4 gives us minus 4, x minus 4 minus 5, we get negative minus 4 minus 1 gives us negative 5. And we bring negative 5 to denominator, and we just get x to 5th power. So the answer is minus 4 our x to 5th power. And one more example, that we have 5 our x to the 7th power. We remember that 5 is the constant multiplier. We do not change it. And derivative of x, 7 positive becomes minus 7, negative 7, and derivative is 5 into minus 7x, negative 7 minus 8, 1 is negative 8. What we get, 5 times 7 is minus 35 x to negative 8 power all, minus 35 our x to 8th power. Let's focus on differentiation radical functions, and the first example is the square root of x. What can we do now? You should remember that square root, what is this? Is here we have power 2, here we have 1. We can rewrite it to natural form, and we will get x to power 1 over 2. And now again we use the same power rule. 1 by 2 moves to the front, and what we get? We have x 1 by 2 minus 1. Half minus 1 is negative half, negative 1 over 2. Again, what we can do? We can bring it to denominator. We have 1 by 2 positive, and 1 over 2, we know that it is the simply square root of x. This is the answer. Derivative of square root of x is 1 by 2 square root of x. One more example. What we have? 3x raised to the 5th power. So the cube root of x to the 5th power. How can we rewrite it? We can rewrite it as x to power 5 over 3. And derivative gives us 5 over 3 x. 5 by 3 minus 1 is like 5 by 3 minus 3 by 3 is 2 over 3. Or we can bring it back to radical form. We will get cubic root of x squared. This is the answer. And let's consider one more example for polynomial function. We will get 2x cubed plus 4 our x squared minus 5 root to the 5th power of x cubed. And let's find this derivative using all we already considered before. Derivative of 2x cubed gives us 2. Derivative of x cubed is 3x squared plus. Here we need to rewrite this function. What we'll get? We will get derivative of 4x minus 2. And this we can write it minus 5. And we will get x to the 3 over 5 power. And here we get the answer. 2 by 3 gives us 6x squared plus. Here we have 4, it remains the same, and minus 2 goes to the front. We'll get minus 8x minus 2 minus 1 is minus 3 minus here what we have here, we have 5. 3 over 5 moves to the front. X 3 by 5 minus 1 minus 5 by 5 is minus 2 over 5. And the final answer is 6x squared minus 8 over x cubed. We can bring it to denominator, and minus 5 and 5 is cancelled. We have minus 3. Negative 2 over 5 in denominator will be positive 2 over 5, but when we bring it to radical form, we'll have fifth root of x squared. So this is the final answer.